What's poppin', everyone? I'm Nuptial Failures, and welcome back to another episode of Bow Maths. Today, we're going to be talking about block heights in Minecraft, and we are going to be looking at literally every single variation of height of blocks in this game. It's pretty crazy, and there's a lot of interesting math with fractions in it, so hold on to your horses. So the first thing to discuss is, what am I talking about with block height? It's going to be specifically with solid block height, so that means it's something that the player can interact with. Like if I run into it, that means, you know, it's got a solid block, I can stand on top of it, it affects my height. So that's what I mean by solid block height. In contrast, if we look up something like a flower, well, this obviously has some height to it. It doesn't affect the player's position at all. You can walk through it, it has no collision to it. So we're just going to be talking about solid blocks that actually have collision and that affect the height of the player for today. Alright, but before we do that, there's just a couple kind of prerequisites that we have to really understand what's going on here. The first, there's a debugging screen in Minecraft, and for most computers that's accessed by pressing F3. And it brings up all this information, looks super complicated, but what we're focused on is that spot where it says X, Y, Z, and that is our coordinates in the game. So the X direction, that is moving east and west, right? The Z direction, that is going to be for moving back and forth, so you see that's the rightmost number that's changing there. And for the Y direction, that is your vertical movement, up and down, and that's what we're focused on today, right? Because we're looking at the heights of blocks, so we're going to be using that middle coordinate quite a lot today. And then the other thing to note, and maybe less of you know this, what is a Minecraft block actually made up of? So each Minecraft model is composed of all these little squares, and you see that the actual art for this, right, there's a bunch of squares, each with a slightly different shade on it, and that creates the whole block that you see before you. And the dimensions of these blocks, and you can pause and count them, but are 16 by 16 by 16. So in each of these blocks there are 16 pixels in the Z direction, 16 pixels in the X direction, and 16 pixels in the Y direction. So we might expect then that the coordinates that we're looking at will be in terms of fractions out of 16. That would be reasonable, where basically 1/16 would be 1 pixel tall, 2/16 would be 2 pixels tall, and so on and so forth. And that's exactly what the case is going to be. So what I would recommend is, for those of you who are watching this in my math series, pause the video and, at least for a few of them, try and convert some fractions into decimal. So I'm assuming you've done that, and I'm going to pull out a cheat sheet. So this is going to be all the conversions of these 16ths. So 1/16 is 0.0625, and so on and so forth, and we've got these conversions all the way up to 16 out of 16. And notice that for some of these, in particular all of the ones with the even numerator, we can simplify them down, right? So 2/16 is 1/8, 4/16 is a quarter, and so on and so forth. So pause the video at these and make sure that you understand all of these conversions here. If not, maybe go back and watch some of my videos on fractions to understand where all of this is coming from. Okay, so let's actually go on and look at some heights. So if I press F3 and I go onto these carpets here, this is our first height. We pull out the book, we see, okay, our Y value is 0.0625, and that is 1/16, right? 0.0625. So we have our first height, and these are going to be 1 pixel tall, right? And we can see on the side that they are indeed one of those Minecraft pixels tall. Alright, so that is our first one, 1/16, or 0.0625. The next one we have is a lily pad. Now if we stand on it, we go a little bit higher, right? 0.09375 if we open our book. Oh, there doesn't look to be 0.09375, right? 0.09375 is a bit bigger than 1/16, but it's smaller than 2/16. So what's going on here? To start with, let's convert this decimal of 0.09375 into a fraction. So we're looking at 0.09375, and if you convert this into a fraction, and honestly I would use a calculator for this, just because if you try and do this by hand, it's a really big fraction that you're gonna have to simplify. The numbers don't simplify nicely, and yeah, there's just gonna be a lot of work involved, and we're just focused on the application, so the focus isn't even on converting the fractions in this video. So I give you permission to use a calculator for this. So what we end up getting is 3 over 32. Okay, so what that says then is that this block is 3 over 32 of a block. Okay, well, how does that work if we're kind of thinking of things in terms of sixteenths, right? Because 1/16 is 1 pixel. What's going on here? Let's go to some pen and paper and work this out. All right, so we are working with 3 over 32. And we know that this is going to be between 1/16 and 2/16. And why is this the case? Well, we saw that the decimals that correspond to these, right? 1/16 was 0.0625, 2/16 was 0.125, and 3 over 32 was 0.09375. So just looking at these decimals, we see that 3 over 32 should go in the middle. If we want, we can also convert 1/16 into a fraction out of 32, and same with 2/16. Right, all we have to do is multiply the numerator and denominator by 2 each, and that's going to give us 2 over 32. And then similarly over here, we're going to get 4 over 32. So now we have a common denominator, and it's nice and clear that 3 over 32 is smack dab in the middle of these two values, right, between 2 over 32 and 4 over 32. But one other thing that we could do is 32, we know that if we divide that by 2, we get 16. So I'm going to do that, and let's see what happens. So if I take 3 over 32, and I divide both the numerator and denominator by 2, 3 divided by 2 is 1.5, and 32 divided by 2 is 16. Now, we haven't formally talked about decimals inside of fractions yet, but just for a second, let's kind of picture this. We have 1.5 out of 16. We know that that is going to be between 1 over 16 and 2 over 16. And we get a nice ordering as well, right? 1.5 is between 1 and 2. The reason we like these fractions out of 16 is because it tells us how many pixels the block is, right? For our carpets, 1/16, that means the blocks were 1 pixel tall. And then moving over, we'll get to 2/16. But here we're just looking at 1.5 pixels tall. Now, some of you may think, okay, how do you get half of a pixel if it's either like on or if it's off? But remember, these are Minecraft pixels. So one of these Minecraft pixels are made up of tons of pixels on your computer. So that means we are able to look at half of a Minecraft pixel because it's still being produced by several pixels that are actually on the screen. So now we understand that that lily pad is essentially 1.5 pixels tall. All right, so our lily pad is 1.5 pixels tall. Let's go to the next row. So the next row, if we stand on top of it, this is a repeater here. The height we get is 0.125, and that is exactly this 2/16 or 1/8. So then a comparator is going to be the same height. So will scaffolding when it's kind of in this pushed out mode, not when it's like standing like that, but if you go up and then move it to the side, the bottom of that scaffolding will be 2 pixels tall, right? Or the 2/16 of a block. Same with the bottom of a lectern and the inside of a composter, also that 0.125, and the bottom of a brewing stand. All right, so that is that row right here. Let's go on to the next row. So if I stand on this row, we're looking at 0.1875, and that is just the next one up, right? Our 3 pixels. Okay, so these are 3 pixels tall, and you can count, you'll see that. Also, these pitcher pods, when they're in their immature state, they are also going to be 0.1875 or 3 pixels tall. And lastly, the small amethyst bud will also be these 3 pixels tall. So that is that row right there. Moving on to the next row here, we're going to have the inside of a cauldron. So that is 0.25, which most of you will recognize as a quarter. And indeed, right, that's a quarter or 4/16. So this is 4 pixels off of the ground. And for an anvil, obviously this is much taller than 4 pixels, but the base, the first little base part of the anvil is 4 pixels tall. And then same with these piston heads here, which if I equip an elytra, I can actually fly down onto these and we'll see, yeah, it's 0.25. And then one of these medium amethyst buds, these are also going to be a quarter of a block tall or 4 pixels tall, that 4/16, right? So that was the 4/16 row. Let's move on to the next row. All right, so in this row, we're just adding 1 more pixel of 5/16, and we look at the kind of second little rim on this anvil here, and that goes up 1 more pixel, right? So we would expect that to be 5/16. And then the pitcher pod, when it's in these other growth states here, so not when it's in this immature state, but when it's growing, that is all a constant height of this 0.3125, which if we look, yeah, it's 5/16. And the large amethyst bud is also 5/16 tall or 5 pixels tall. All right, so now the next row we're looking at, well, we would probably guess would be 6 pixels tall, right? We just did 5. So let's see, 6/16, that is 0.375, and indeed, yeah, that's our Y value, right? So we got a daylight sensor, we have a pot, the first 3 stages of sea pickles, but the 4th stage, that's actually going to be a bit taller. It's going to be in our next row. And the next thing we have here is a bell, not the whole bell, that's obviously taller, but just kind of this bottom rim part of the bell. If you're really careful, you can actually get onto it. And yeah, you see here we got 0.375, and I am standing on top of the rim of the bell there. So that is also going to be 0.375 or 6 pixels tall. All right, and then we have candles. All of the candles are also the same height of 6 pixels tall. All right, the next row, probably going to be 7 pixels tall, so 7 is 0.4375, and indeed we're at 0.4375. So all your campfires, your 4 sea pickles, so the first 3 are 6 pixels tall, but the 4th one, when you add it in there, that takes it up 1 more pixel of height. All of your turtle eggs are going to be these 7 pixels tall. And then also the outer rim of your lanterns, when they're just on the ground like this, are also 7 pixels tall. So if I just try and stand on top of it there, yeah, we get 0.4375, right? So that is 7/16 or 7 pixels tall. And lastly, your amethyst cluster, so the big boy here, that is also 7 pixels tall. Now, it is a lot bigger, right? We notice that there's way more than 7 pixels in our vertical height here, but if you look at the black rectangle around it, that is the actual collision box of this block here. So anything above it, that is just kind of some added fanciness, but if we just count the pixels inside of the collision box, then that is actually going to be 7 pixels tall. So that is the part that we care about with this block. All right, moving on. So next row here, you see it is a half slab. So most of you already know that a half slab, as in the name, will be a half of a block. So we would expect that to be 0.5, and we stand on top of it, yeah, it's 0.5. So every half slab in the game, I was too lazy to put all of them because there are dozens of them, will be this height. And then similarly with stairs, just this bottom part of the stair is the same height as a slab. Cake is the same height as a slab, and then all of these heads as well, including the dragon head. Despite it looking taller, its collision box is also just 0.5, or half of it, or right, 0.5 is 8/16, so this is 8 pixels tall. We also get in this row a hopper, not the inside of a hopper. If we stand inside of a hopper, we get 0.6875, so that's going to come a little later. However, the mouth part of a hopper, when it's facing to the side here, that is going to be 8 pixels off of the ground. And I've also got 3 blocks of skulk over here to remind me to come over to this chest here and grab these blocks, which are also going to be a half of a block tall, but as a lot of you know, these are very noisy blocks, so I didn't want them going off the entire time I'm doing the demonstration here. But yeah, these blocks are also a half of a block tall, or 0.5. So when chains are hanging, kind of the outside of this block here, just along the rim, is also 0.5. It's a little bit taller than over here because they're hanging, right? They're a little bit off of the ground there. So this next row here, if that was 8 pixels tall, we would expect is probably 9 pixels tall. So we have 0.5625. If we check our book, 0.5625, yeah, that's 9 pixels tall. All right, or 9/16 of a block. So beds, stone cutters, so I put 2 down for some reason, with grindstones that are facing up, so you put them on the bottom of a block. Just this little rim of the wooden part here, that is also going to be 9 pixels tall. Boats, technically these aren't really blocks, but they do have a collision to them, so I figured they are worth noting. They are also these 9/16 of a block tall. And then for lanterns, once again we're at lanterns, but this time it's the top piece of the lantern. So when we stand on the top piece of the lantern, we also get to that 9/16, so it's a bit higher than the outer rim of the lantern. All right, let's move on to the next row. So this was 9/16, so we'd probably expect this to be 10/16. So we stand on top of it, gotta go over to the 10/16 spot. All right, that's 0.625. Ooh, that's not our Y value, and our Y value is bigger than 9/16, so it's somewhere between 9 and 10. Okay, so I guess we're getting another lily pad situation here. So we got to convert 0.59375 into a fraction. Once again, I give you permission to use a calculator for this. And what you're going to end up getting is 19/32. All right, so that's a little bit of a gross fraction, but let's go to the paper and analyze what this means. All right, so we're looking at 19/32. And we noted that that is somewhere between 9/16 and 10/16. And we can show this by making a common denominator, right? So 9/16 we can express as 18 over 32 if I multiply the numerator and denominator by 2 each. And 10 over 16, right, to get that denominator of 32, once again multiply the numerator and denominator by 2 each, and I get 20 over 32. And we see that works out nicely because 19 is smack dab in the middle of those. But then, just like we did up here with our 3 over 32 for the lily pad, I'm going to convert 19 over 32 into a fraction out of 16 by dividing the numerator and denominator by 2. And I do 19 divided by 2, what do I get? I get 9.5. And 32 divided by 2 is 16. So now we see, okay, this is nice and in between the fractions of 9/16 and 10/16. And furthermore, we see that since it's a fraction out of 16, we get the context of how many pixels this is, which is going to be that 9.5 pixels. Just like with the lily pad has a half of a Minecraft pixel in there. All right, so we're looking at 9.5 pixels here for a sideways chain. So that's from the top of it to the bottom. Of course, it's kind of suspended off the ground, but several of those air pixels in between are also included in that 9.5. So that is this row right here. Let's move on to the next row. So we had 9, 9.5. This is probably 10. So 10 is 0.625, and yeah, we're at 0.625. So lightning rods and end rods. And for the sideways sticking grindstone, this kind of bottom wooden part is also 10 pixels tall. And then for finally hanging chains, the top piece of it will also be 0.625. And then for pistons and sticky pistons, the arm piece of it is also 0.625 or 10 pixels off of the ground. So now this row, probably going to be 11 unless we have another 32 situation. So standing on top of a conduit here, we're at 0.6875, which is 11 over 16. So these are 11 pixels tall, the inside of a hopper. And then for a sideways facing grindstone, the top piece of the wooden arm now is that height. So it's just 1 pixel taller than the previous. And we see, yeah, it's just 1 pixel taller than kind of this lower wooden piece of the arm. A dripstone is also 11 pixels tall. All right, moving on to this row here. For all stages of cocoa bean, if we stand on top of it, we get 0.75. All right, so all stages of cocoa bean are 0.75, 3/4, or 12/16, so 12 pixels tall. The grindstone, when it's facing up like this, the actual stone piece of it is also 3/4 of a block tall. And then all the heads when they're mounted on a wall, including the dragon head. And then when the pistons are facing up like this, just this stone base of the piston is also going to be 3/4 of a block tall, which we can verify by using our elytra, right? And for the small amethyst bud, when it's off of a wall like this, as you'll sometimes find it naturally generating inside of geodes, that is also going to be 0.75. In this row here, let's see our height, we're at 0.8125, which is 13/16. All right, so these are 13 pixels tall. So our ender portal frame, those are 13 pixels tall. With an eye in it, when you actually stand on top of the eye, it takes you up to 1 block, but the side of the portal is still that 0.8125 or 13 pixels tall. Okay, next up we have chorus plants with no fruit on top of it. That is also going to be 13 pixels tall. And then for grindstones that are facing up, the wooden part of these sides here is also 13 pixels tall. And then for bells, just from the bottom to the actual top of the bell itself, so not the wooden part, but the top of the bell itself for both of these is going to be 13 pixels tall. And then for drip leaves, when you stand on a drip leaf, as most of you know, it'll fall down like that. But it has 2 stages of falling, right? One stage where you kind of get a little chance to get off of it, and then you fall completely through the block on the second stage of it falling. So on that first stage of it falling, let's look. Yeah, we get to 0.8125 as well. And to finish off the 13/16 row, we have all the other sides of the amethyst clustered when they're on the side of a wall here. All right, the next row, we've got soul sand, which is at 0.875, as is our mud block. So at 0.875, that is 14/16, so we're just 1 pixel up after the next one. And then a birthday cake is also 14/16, but specifically with a candle on top. So when you stand on top of the candle, it is 0.875. But when you're on the edge of the birthday cake, it goes back to a half like we had over there. But an interesting thing with this is that a birthday cake, that is a half, or 8 pixels tall, right? And a candle over here, this was 6 pixels tall. So if we do 6 pixels, right, 6/16, plus 8 pixels, 8/16, we get 14/16. What is 14/16? That is 0.875, which is exactly the height of this candle, which is on top of the birthday cake here. So they just added those two heights to give us this, which is kind of cool. Although maybe it's not super realistic, because that means just the candle is completely on top of the birthday cake and not submerged at all. So maybe we should start a petition to submerge the candle in the birthday cake, maybe lower it by a pixel. In any case, we also have the lectern and the grindstone facing the side, just the stone part of it this time. Those are also going to be 14 pixels tall, and all of your chests, your regular chests, as well as your trap chest and your ender chests, are also 14 pixels tall, or 0.875, and so is your brewing stand. All right, we're getting close to full blocks here, right? So we're on probably 15/16. Let's see, 15/16 is 0.9375, which is our Y value. Yep, so we're at 15/16 here. So dirt paths, farmland, honey blocks, cactus, are all at that height here. Bell with the wooden part on the top, so not the bell anymore, but actually the wooden arm of it, is also 15/16 of a block, and so is dripstone when it's in this kind of upstate here. All right, so that is all of your kind of fractional blocks. Now we're getting into 16/16, which is just 1, right? 16 divided by 16 equals 1. So this is just all of your standard blocks in the game. I put a few here, but of course there are hundreds of them, so I am not going to put them all on display here. But yeah, most of your Minecraft blocks are just kind of your standard 16 pixels by 16 pixels by 16 pixels, and they fill up the entire space of the block, and they are going to be just the height of 1, right? So we look, yeah, we're at a height of 1. All right, so now we have some blocks that actually go above 1 block tall. So over here, we've got some pistons, and the whole height of a piston when it's extended is 2 blocks tall. All right, that's nothing new. However, if we look at just the height of the piston arm with the head here, we will see that it's a little bit bigger than 1 block, right? In fact, it is going to be 1 1/4. Remember, the medium amethyst bud was 1/4 blocks tall, or 4 out of 16 pixels. So we see that the medium amethyst bud takes us exactly to the height of this piston arm. So the piston arm is 1 1/4, or 20 pixels tall. You could even count that as well if you wanted, right? So that is the only block, or I guess 2 blocks, right, piston and sticky piston, in the game that is 1 1/4 blocks tall, just the arm piece. All right, and now over here, we've got our 1 1/2 tall blocks. So if I stand on any of these walls, we're at 1.5. If I stand on any of the fences or the fence gates, we're also at 1.5. Of course, these blocks are visually only 1 block tall, but when you stand on it, you see that there's a bunch of airspace between you and the actual fence or the wall, so that extra airspace accounts for the rest of the pixels, right? So we get 1 1/2 blocks tall, or 24 pixels. But also on shulker boxes, when you open them, you also go up in height as well to 1.5. And I did notice when you slow motion this, you do go to slightly higher than 1.5, which is kind of interesting, but that might be just part of like the actual animation of the box. Maybe you're kind of moving up a little bit and then you're kind of settling back down to 1.5. Okay, so we know all these block heights, and there's a bunch of technical things you can kind of take advantage of using different heights that many Minecrafters have taken advantage of over the years. But one kind of maybe immediate thing we can do with these is make a staircase out of them. The most gradual staircase possible, in fact. So we got one here, just kind of going up. We see we're using all of the different blocks we've used, and we get up to 1, right? And that has spanned over 17 different blocks, 18 if you want to include the block we started on, just to go up a height of 1. So it's an extremely inefficient but very gradual staircase. And here's another one just for reference. So we go over to piston arm, and we finish off at 1 block here as well, right? And they're the same length because we're using 1 block from each of these categories. All right, so before we finish up, you might notice there's a couple things I've neglected. First of all, I've got some of these boots along here. What these boots represent is these are just the blocks that you can basically auto step onto, so you don't have to jump. The game just kind of puts you on top of these blocks when you run into them. But where that gravy train runs out is after 19/32. So after 19/32, you are not able to step up onto a block automatically, so the sideways chains is where it stops. And then 10/16 and on, that is where you actually have to jump up in order to get onto the block. And then the other thing that I've neglected to talk about is snow. So snow is kind of interesting. So if we look at snow and we place 1 block down, we see that it is 2 pixels tall. So we would expect maybe to go up to 1/8, which is 0.125. But when we stand on top of here, oh, we're actually just at 0, right? So the idea is that, you know, you're a bit submerged when you're standing inside of snow. It's like kind of a realism thing, I guess. However, once we start adding layers to snow, if we add 1 layer, then we actually go up a block, right? So it's kind of like offset by a block. So 1 layer, there's no height to it. 2 layers though, we go up 1/8. 3 layers, we go up 2/8 or 1/4, right? So we're at 0.25. 4 layers is 3/8 and so on and so forth. So we got 5, 6. So this is 7 layers here, which means since it's offset by 1, we would expect this to be 6/8, which 6/8 is 3/4, that's 0.75, and then this will be 7/8. If we get 9 layers, then we would expect 8/8 or 1, right? So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so visually, we see that we have basically 1 block here, and then an extra layer on top, which should work, right? A block with a layer on top of it. You know, we're at exactly 1 because that extra layer doesn't do anything, so we should also expect to be 1 here. Oh, we're at 0.875 again, which is what we were over here. So now it's not counting 2 layers all of a sudden. Okay, that's kind of strange. So what's actually going on here? Well, when we put a snow layer on top of a normal block, it's calculating the height of the block below it and saying, okay, that's my height. So we stand on top of it, and the height is 1, right? Because that's the height of the block below it. But over here, when we put the layer on top, it's calculating the height of the block below it, but the height of the block below it is being calculated as this over here, which was the 0.875. So putting another layer on top, we actually end up getting 0.875 again. And then this is the really weird part. If we put another layer on here, okay, it's going to calculate the block and then 1 layer of snow, right? So if I stand on top of it, we get to 1.125, right? That's 1 1/8. However, over here, if I add another layer on it, it jumps us up to 1.125. So it starts calculating like normal again. But the interesting thing is just going through these layers of blocks, we get to 6/8, 7/8, and then we add another layer, stays at 7/8, and then we add yet another layer, and it goes up past 1 to 1 1/8. So with snow layers, you can actually never make a single block increment, right? It just skips over that 8/8. So maybe that's a feature. It's kind of a weird feature if it is. I think it's probably just a little bug in the game's coding where it's calculating the height of the block below it incorrectly because the height of the block below it is the height of these snow layers. But in any case, it's kind of an interesting little aspect of the game, let's call it. Alright, well, I hope you found that interesting. We talked about a lot of different ideas today. Maybe some of you found it a little boring, but for the real Minecraft nerds out there, you probably found it somewhat interesting. So this is, yeah, a pretty exhaustive list of all the different blocks in Minecraft, all the different heights. If you want a kind of a reference for this, if you just go into the Minecraft wiki, there's a page for block heights, and that's what I used to actually get my reference here. So it's quite useful. And I hope you found the math interesting in this video where we're using not just the coordinate system to tell us where we are, but we're converting it into fractions to kind of tell us, well, how many pixels are we working with here, right? How many pixels have we traveled? So it's kind of an interesting idea in that regard, and we can do some interesting math with it, as I hope you have seen. So normally with these application videos, I don't do exercise videos to accompany it because they're just kind of meant to be like little one-off topics, but I think there's like a lot of little details that I have left out of the video that can be made into interesting exercises. So I will see you for another episode inside of this Minecraft world. I hope you're looking forward to it. But until then, you have a good one, you stay groovy, and I'll see you in that next episode.
F.O.A. math.